chapter which is classification of elements and periodicity in properties, right? So it's a chapter third, right? And this chapter is a turning point in our understanding, right? Means how chemistry is organized, and how elements behave. Okay. So first, let me ask a quick question. So, have you ever wondered why elements are arranged in a certain way in a periodic table? Why the sodium is placed next to the magnesium and why not somewhere else? Right? क्यों होता है ऐसा? Why? कभी आपने सोचा ये?
So,
Yeah. So, or why do elements in the same group behave in a similar ways, right? So, well, this chapter will answer all of that. Okay, so we will see each and every concept in this, how the periodic table developed, right? And each and everything, कैसे कैसे elements हमारे discover हुए and how they behave similar, like same group में अगर elements होंगे तो they behave just similar ways, right? And for example, okay, so we will discuss it later. Okay, so what is this chapter about? So this chapter focuses on how scientists discovered a pattern in the chemical behavior, right? So how scientists discovered a pattern in the behavior of elements, and they used to classify them. They used to classify the elements based on their behavior, their physical and chemical properties. Okay, so over time, this classification led to the development of what we called now as a periodic table. Okay, अभी जो हम जैसा periodic table देखते हैं, like modern periodic table, starting में वो ऐसा कुछ भी नहीं था. Okay, because 118 elements उस time discovered नहीं हुए. ओके, सो अर्लियर अटेम्प्ट जो हुआ था, सबसे पहले जो अटेम्प्ट किया था पीरियोडिक टेबल जो उन्होंने दिया था, ही वाज अ डॉबराइनर, राइट? सो व्हाट वाज द नेम ऑफ द साइंटिस्ट हु गेव द periodic table first? So let's see. First, just first Dobereiner gave a triads, right? First, we will discuss the Dobereiner triads. Then Newland's Newland's law of octaves. After that, Mendeleev, Mendeleev's, he gave a periodic table, and after Mendeleev's, the modern periodic table. Okay, so in this train we will see. Okay, step by step we will see what is Dobryner's triads and what is Newland's law of octaves, Mendeleev's periodic table, and modern periodic table. Okay, we will see in details each and everything. And yeah, why? Here's a question: why it is important? Why the classification of elements and periodicity of elements is important? Do you have any answer? Anyone? Why we arrange these elements according to the atomic numbers and all, according to the chemical and physical properties? Hmm? Yes? Anything you know about? Just tell me.
to make it easier to
Yeah, to make it easier to what? To study the chemical and physical properties of all the elements, because there are 118 elements, right? At that time, like 31, like in 1800, see, in 1800, at the time of Dobereiner, so us time 31 elements were known, right? And by 1865, more than 63 elements were known. Okay, but till now there are 118 elements unknown, right? So scientists, because there were with such a large number of elements, it is very difficult to study individually the chemistry of each and every element, right? It's very difficult because there are 118 elements, right? तो सबकी एक chemistry हम पढ़ेंगे तो बहुत ही difficult होगा. Yes, Hafsa, is there any question?
No, ma'am.
Okay, so there are large number of elements, and to study each and every element's chemistry is very difficult, right? So to ease out this problem, scientists searched for a systematic way, right? Systematic way to organize their knowledge, right? By classifying these elements. That's why they gave the periodic table, right? So they just arrange the elements according to the atomic numbers, right? And based on the chemical and physical properties, they just give the periodic table so that we can easily just study the each and every element's chemistry, right? So that's why this periodic table is important. Got it?
Yes, ma'am.
Yes, ma'am.
And now till now, how many elements are known? 180 elements are known. Okay, so let's see one by one. Right. So the genesis of periodic table. So these are known as genesis of periodic table, periodic classification. So what is genesis? So basically it's a historical development of periodic table. How the periodic table developed from the very simple to the very complex. Okay. So that's the genesis. We called it as a genesis. These are known as genesis of periodic classification, you can say. Okay, so how the periodic table developed from a simple to the very complex. So we will see the historical development of periodic table one by one. Okay, step by step, we will see the history, how this modern periodic table came. Okay, so see first, write down the heading first, Dobereiner, Dobereiner's trials, trials. Okay, so just make notes along with me. So in 1829, in 1829 or something like 1800 से 1829 के बीच में ये ट्रायल्स दिया था उन्होंने, right? So you can write 1800. Just John Dobereiner in early 1800, he was the first to consider the idea. Okay, he just gave the idea to train among properties of elements, right? He just gave the idea. So 1800 से आप 1829 you can write down the date. Okay, so between these, he just gave the Dobereiner prize. Okay, so in 1800, you can write, instead of this, you can just write 1800. Dobereiner arranged certain elements, right, with properties, similar properties in groups of three, right? He just gave the triad. Triad means three elements. Triad means three, right? Triad का meaning ही होता है it's three. So he just gave a group of three elements in such a way that the middle element, see, that the middle element atomic mass is just an average of the other two. See that this see this table. Okay, so he just said that the see he gave the three triad, first triad, second triad, and third triad, right? Triad, we know that there are three elements in the triad, right? So three, lithium, sodium, and potassium, three elements were there. So he said that the atomic mass of the middle one, right, is equals to the atomic mass, the mean of the atomic mass of the first and third, right? फर्स्ट लिथियम एंड पोटेशियम का जो एटॉमिक मास का जो अर्थमेटिक मीन होगा, एवरेज होगा, दिस इज ऑलवेज इक्वल्स टू द मिडल मिडल एलिमेंट के एटॉमिक मास के. You can check it. The atomic mass of sodium is 7, right? Potassium is 39. And the you can check the 39 plus 7, right? Divided by 2. So you will get 23, right? You will get 23, which is equals to the atomic mass of sodium. Okay, so that's what the Briner said. He just gave the triads. He said that the atomic mass mean of the first and third element is equals to the atomic mass of the middle one. Clear?
Yeah, ma'am.
Yeah, Hafsa and Asha, is it clear?
Yeah, ma'am. Yes,
Okay,
ma'am.
second you can see. Second triad. Again, similar things. The calcium, the mean of the atomic mass of calcium and barium is equals to the atomic mass of strontium. Okay, so 40 plus 137 divided by 2, it will give you 88.5, which is equals to the atomic mass of your strontium. Okay, so approximate value, you can take the approximate value like 88.5 है, तो you can write 88. So strontium के equal था, atomic mass के equal. Okay, third third triad was chlorine, bromine and iodine. Okay, because उस time सारे elements उस time discover नहीं हुए थे, right? Only 31 only 31 elements were there known. Okay, सारे elements known नहीं थे. So he just gave these three triads only. These three triads: first triad, second triad, and third triad. Okay, so these are the three triad which was given by Dobriner triad. Okay, John Dobriner ने who just gave in early 1800, 1800s में उन्होंने दिया था. Is it clear?
Yeah, ma'am. Yes, ma'am.
Okay, you can write down the statement of this. He arranged certain elements with similar properties. Similar properties in groups of three. Right, and these three have, according to the Dobriner, these three have a similar properties, right? Similar physical and chemical properties. That the atomic mass of the middle one was was nearly same as the average of the first and third element. Okay, so these are the few triads which was given by Dobrine. Also write these triads. And the major limitation of this Dobriner triad was that it was restricted to only few elements. Right? He just talked about few elements only. That's why it was discarded later. Right? Later इसको discard कर दिया. Why? Because only few elements के लिए ये restrict था. Other elements का उन्होंने बताया नहीं था Dobriner. It was not applicable for the other elements. Only three tried he just gave. That's why it was discarded. Also write down the limitations. What he could done?
1 second.
Yeah, okay. What he could done? Arrange all the elements known at that time. And everyone,
Mom, done.
Okay, everyone, written.
Yeah, mom.
Okay, so the next is your Newland's law of octaves. Okay, so Newland, he was the first to correlate the chemical properties of elements with their atomic mass. Okay, इससे पहले क्या था, डब्राइनर ने atomic mass से correlate नहीं किया था, correlate तो किया था but the chemical properties को नहीं किया था, right? So Newland was the first to correlate the chemical properties of elements with the atomic mass. Okay, so atomic mass से correlate किसने पहले किया था, तो he was the Newland was the first one. Okay, and yeah, first write it down, then I will explain. Yeah, atomic mass. And yeah, according to John Newland, according to this octave law of octave, so if the elements are arranged, you can see in the picture, if the elements are arranged according to the in order of increasing atomic number, right? Atomic weight, you can say. So, in order of, if you arrange the elements according to the increasing atomic weight, the eighth element, starting from the first, like this is the first, right? First, and when you count this from the first, so from the beginning first, the eighth element of this series is similar in properties to the first element. ओके, अगर आप फर्स्ट से यहाँ से स्टार्ट करो और उन्होंने क्या कहा था, सा रे गा मा पा धा नी, right? And it also called it as do re mi fa so la ti, right? So accordingly he just gave the Newland's law of octave. Octave means eight, right? He just gave the eight elements की उन्होंने series बनाई, right? He just gave a series of eight elements and he said that the first element and the eighth element properties are similar, right? They have similar properties. Starting from the first element and the eighth element have similar in properties. Okay, and this arrangement of elements is known as Newland's law of octaves. Octaves means eight. So there are eight elements here, right? Yeah, he just, you can see over here, this is Sare Gama Padhani. So it's a musical notes, right? So this Newlands called it as a law of octaves. Why? Because it's a similar relationship exists in the musical notes, right? Musical notes may be similar, a similar relationship hota, like first and your eighth one has a similar properties, right? So he just take the relationship from there, like musical notes, Sare Gama Padhani, and he just gave this law of octaves, and he said that first element, like every first element has the similar properties to that of the eighth element. अगर आप यहाँ से for example this hydrogen यहाँ से start करते हो, 1 2 3 2 3 4 5 6 7 again 8, right? 8. So this hydrogen and this fluorine, they have similar properties according to this Newland octaves theory. Okay, similarly, if you these numbers like sa, ये जो sa है, this hydrogen, fluorine, chlorine, cobalt and nickel and bromine, these have similar properties, right? These have similar properties: lithium, sodium, potassium, copper, etc. Rubidium, right? These have similar properties. So according to Newland's octaves theory, he said that when you start from the first, right? So first and the every eighth element have the similar properties, and he called it as a law of octaves. Clear?
Yes, ma'am.
Okay, if there is any doubt in between, you can ask. Okay, just stop me and ask. So just write it down. According to octave, the law of octave, if the elements are arranged in the order of their increasing atomic weight, the eighth element starting from the first is similar in properties to the first, to the first element. Every first and eighth element has the similar properties according to the Newland. Yeah, and it has also a limitation, right? Because this classification worked quite well for the lighter elements. Okay, like till calcium, he just gave this law of octaves. उसकी further उन्होंने नहीं बताया, right? So he just gave the this classification for the lighter elements only, right? He failed in the case of heavier elements. Doesn't that didn't give the law of octaves for the heavier elements. Okay, so that's why it was discarded. Okay, so that's why it was discarded. So that's the major limitation of Newland's law of octaves. Till calcium, he just gave this law.
Ma'am, between which year?
Yes,
Year.
between which year? So he just
Yes.
gave this in 1865. In 1865, he just gave this law of octaves. And his full name was John Alexander Newland. John Alexander Newland. If you want to write down the year, you can write in 1865.
Can you scroll up to the dates? Thank you, ma'am.
Yeah, at this time in 1865, Newlands के time till I think 60 to 65 elements were discovered. Okay, at the time of Dobrina, only 31 elements were discovered, but at the time of Newlands, 63 elements were discovered. Okay, but he just gave the law of octaves till calcium. Right, it's only true only for the elements up to calcium, not for the heavy atoms elements. So written till here.
Yeah, ma'am.
Yeah, let's write down the limitations. So this classification was successful only up to the calcium element, up to the calcium. After that, every eighth element did not possess the same property. And you can see over here in the table, they have not given for the noble gas, right? Because noble gas was not discovered at that time, right? So when noble gas elements were discovered at the later stage, so at that time, there this Newland's law of octaves, it become discarded. It just discarded, right? Because that noble gas doesn't follow this octave. So when noble gas, right? So when the noble gas was discovered at a later stage, so when they are included in the table, so just disturbed the whole arrangement. Okay, whole arrangement was just disturbed due to the noble gas elements, and this Newland law of octaves were discarded. That's the limitations of Newland's law of octaves.
Mom, how does the arrangement get disturbed by noble gases?
Because noble gas doesn't follow this law. Means अगर आप noble gas इसमें fill करोगे accordingly, like noble gas, we know that helium, right? Helium, neon, and all. So after hydrogen, it comes helium, right? Second number पे. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and here neon, right? On the 10th number, 2, 10, 18, and so on. So this 1, 2, 3, and 4, ये जो arrangement था, ये disturb हो गया था. Why? Because here, without this noble gas, this hydrogen and fluorine, they, because first element, right, and the eighth element, according to the Newland law of octaves, they have similar properties. But when they are included in the noble gas are included in this table, the whole arrangement disturbed, because after, if you arrange this, like see, hydrogen, then helium, then lithium, then beryllium, boron, right? Carbon, nitrogen, oxygen, fluorine, and neon. Right. So this is the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and this 10th, right? And according to the Newland's law of octaves, this first element and the eighth element, right? They first element and the eighth element, they have similar properties, right? So, but accordingly, when the noble gas are included in this table, this hydrogen and oxygen, they don't have a similar properties, right? तो ये पूरा setup जो पूरा whole table था, the arrangement just get disturbed due to these noble gases. Okay, because properties same nahi ho rahi thi when they are included in the table. Without these noble gases, the properties were same. Like first and eighth element के जो like hydrogen and fluorine की जो properties थी, they were same. Okay, lithium and sodium की जो properties थी, they were same. Okay, but when they are included, the whole arrangement disturbed due to these noble gases. Clear? Aisha, got my point?
Yeah, ma'am, got it.
Okay, so the next one is your Mendeleev's periodic table. Let's see what does Mendeleev said. Okay, so according to the Mendeleev periodic table, so Mendeleev periodic table, it was given in 1869, in the year 1869. He just gave the Mendeleev's periodic table. Okay, or sometimes in some books, just they give like in between 1834 to 1904, right? 1834 to 1907, इसके बीच में ये डेवलप हुआ था, ये मेंडलीव्स periodic table. Okay, so Mendeleev, he was a Russian chemist, right, who gave this periodic table, and according to him, the physical and chemical properties of the elements are the periodic function of their atomic mass, right? He said that physical and chemical properties of all the elements are the functions of their atomic mass. They just depend on the atomic mass, right? According to the atomic mass, the physical and chemical properties changes for the elements. Okay, he just said that, Mendeleev. And he arranged the known elements. Us time, I think 63 elements were known, right? At the time of Mendeleev, when he gave the Mendeleev's periodic table, 63 elements were known, and he arranged the known elements in order of their increasing atomic masses. Okay, and he considered the facts that elements with similar properties should occupy the same vertical column, right? Same vertical column, and he just left blank जहाँ पे जो भी elements वहाँ पे उन्होंने blank छोड़ दिया जिसके बारे में उन्हें नहीं पता था, right? He just left blank, right? Which is, see here, this, right? These are the Dobrunner triads, right? Like this is lithium, sodium, potassium, and calcium. It was given by the Dobrunner, right? So ये triad के लिए उन्होंने Mendeleev's ने Dobrunner triad से ये elements लिए थे, right? And these this solid blue line, it just gave the Mendeleev, right? They are known to Mendeleev's periodic table only. Okay, and you can see over here this yellow line, they are the lanthanoid series. Okay, means your inner transition metals. Now let's see, first discuss what is transition metals. Transition metals, we will discuss it later, but let's see. So transition metals are those type of metals, those metals which have incomplete d subshell, जिसके incomplete d subshell होते हैं, right? Fully filled नहीं होते, उसमें incomplete d subshell होते हैं, right? And they have variable oxidation state. They have variable oxidation state. Oxidation state दो तीन होते हैं, variable होते हैं oxidation state. And this transition metals, if you see the modern periodic table, so they just occupied. If you see the modern periodic table, तो location कहाँ होता है इसका? So it just occupy the central part of the periodic. Okay, especially D block elements जो होते हैं, so they are transition metals. D block elements are transition metal elements. Means your group 3 to group 12. Okay, when we see the modern periodic table in detail, so we will see each and everything, where the location of these transition metals are there, कहाँ पे S block elements होते हैं, कहाँ पे P होते हैं, each and everything we will discuss in details. Okay, but transition metals यहाँ पे name आया, so you should know what is transition metals. So metals that have incomplete d subshell, okay, and they have variable oxidation state. और ये कहाँ पे lie करते हैं in the periodic table? So they just lie between, means center part, right? Center part में ये lie करते हैं. Clear?
Yeah, ma'am.
Okay. So he just arranged the known elements in order of their increasing atomic mass. Okay, and he said that elements with similar properties should occupy the same vertical column. Okay, just similar properties hai, they occupy the same vertical columns. These columns you can see in the pink: helium, neon, argon, krypton, xenon, radon. Right, these have similar properties. Right, they are noble gases. Right, so they have similar properties. So he just arranged those elements in a vertical columns. Right, he said that elements with similar properties, they should occupy the same vertical columns, and he just left spaces जहाँ पे उसे लगा कि कुछ और भी आगे फर्दर वहां पे डिस्कवर हो सकता है, राइट? जिसकी प्रॉपर्टीज उसे नहीं पता थी, बहुत सारे एलिमेंट्स ऐसे थे जिसकी प्रॉपर्टीज ही डजंट नो, सो उसके लिए उसने ब्लैंक स्पेस छोड़ दिया, राइट? ही जस्ट left the blank spaces where he think it is necessary. Okay, now this table was divided into 9 vertical columns. You can see over here, there are 9 vertical columns. Okay, and which is known as groups. 9 vertical columns, which is known as groups, and 7 horizontal rows. They are called periods, right? They are called periods. Just remember what is periods and what is rows. Don't be confused in that. And groups, right? So groups are basically vertical columns, right? And your periods are basically or horizontal rows, right? So according to this Mendeleev's periodic table, how many groups are there? So there are 9 groups according to it, right? According to Mendeleev's periodic table, there are 9 groups only. But according to, yeah, and periods kitne the? So periods are 7 periods. Clear?
Yeah, ma'am.
Yes, ma'am.
Let's write one by one. साथ साथ हम लिखते भी जाते हैं और साथ साथ I will explain it. Okay, so let's write down the characteristics. So according
Ma'am, can you
to,
scroll up to the table?
yeah, just you can take the screenshot of this. Done?
Yeah, ma'am.
So according to him, the physical and chemical properties. Or their atomic masses. Okay, so these are the descriptive features of Mendeleev periodic table. Okay, I'm just writing it in point wise. Right, and this arrangement was a periodic table. And according to Mendeleev's elements with similar characteristics, if I'm saying characteristic, it means physical and chemical characteristics were present in vertical rows. And vertical rows, we call it as a group. Just a second. It's a vertical column, right? Vertical column is known as groups and horizontal rows. Okay, and according to Mendeleev, there are how many periods are there? So there are basically 9 groups, which are indicated by Roman numerals, right? Mendeleev, he just indicated the 9 groups as a Roman numerals as 1, 2, 3, right? 4, 5, 6, right? 7, 8, and the last one with 0. Right, so these are the 9 groups 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 8. Yeah, you can see in the periodic table. Yeah, this is zero group, first, second, third, fourth, fifth, sixth, seventh, and this is eight. You can see eight groups को उन्होंने triad में arrange किया था, right? Eighth group, the group eight, it consists of nine elements, right? You can see iron, cobalt, nickel, all these elements, right? Nine elements were there, which were arranged in a three triad. Three triads में उन्होंने arrange कर दिया था, and all these are known as group eight, right? Group eight element. Okay. So what is group? So group are the horizontal column, sorry, vertical column, right? And there are nine groups according to the Mendeleev's periodic table. 0, 1, 1 to till 8, eight group. Okay, and all the groups name are written as Roman numerals. Okay, so आप 1 to ऐसे नहीं लिख सकते like 1, 2 and so on. Like he just write the name as a Roman numeral. So you just have to write down accordingly. Okay. Now see, so nine groups were there, right, in the Mendeleev's periodic table, and to this group you can write group 8, right? Consist of it consists of nine elements, right, which were arranged in three triads. Three triads. And the zero group, basically you can see in the periodic table, Mendeleev periodic table, zero group, it contains the inert gases, right? Means your noble gases, helium, your neon, right? Your krypton, xenon, your rubidium, right? Sorry, it's radon, right? Helium, neon, argon, krypton, xenon, and radon. This group zero, it consists of a noble gas, which is an inert gas. Okay, noble gas is also known as inert gas. So zero group consists of, when you see the modern periodic table, you will see there is many changes in this Mendeleev periodic table. Okay, बहुत सारे changes आएंगे, and that's the modern periodic table. Modern periodic table we just use in the अभी जो हम use करते हैं, that's the modern periodic table. Okay, and these were the ancient ones. Zero group consists of your inert gases. Right? Why these gases were kept in zero group, right? तो क्यों उन्होंने रखा ये जीरो ग्रुप एलिमेंट्स को? why only zero group elements में in noble gases को why they put in this group zero group, right? So why, the question here comes, why the noble gases were put in the zero group? So why? Because the noble gases, these elements have zero valence, right? तो इनकी zero valency होती है, they are inert, right? So that's why they are put in the zero group. Okay, so just remember the reason. And how many periods are there? According to Mendeleev, there are 7 periods. And the periods were named as numbers like 1, 2, 7. Right? 1, 2, 3, 4, and 7. Okay, and we know that what is period? So it's a horizontal rows in the Mendeleev period. And yeah, so after the Dobryner's and Newland's law of octaves, this was a very this you can say it was a very achievement, right? ये बहुत बड़ा achievement था, big achievement था in the history of your chemistry, right? ये जो हमें मिला था like Dobryner's after the Newland's law of octaves. So after that Mendeleev's he gave this periodic table, and this at that time it was very successful, right? उस time ये बहुत successful रहा and काफी दिनों तक ये चला, and there are many importance of Mendeleev's periodic table, right? Now let's see what are those importance, why it is important. So let's write down importance of Mendeleev periodic table. Yeah. So you can see in the see this Mendeleev's periodic table. So this periodic table it made the study of the elements quite systematic. Right? यहाँ पे you can see you can just see the you can see the Newland's law of octaves, and after that just see this. Okay, Mendeleev's periodic table. So this made the study of elements quite systematic, right? In the sense of the properties of elements, right? And he just talked about the group, right? Group and your period. So it's quite systematic, right? It's quite systematic और देखने में भी काफी अच्छा लग रहा है, right? So that's Mendeleev's periodic table is quite systematic to study the properties like chemical and physical properties of element which is present in a group. And he also said that the elements which are in the same group has similar properties, right? They have similar characteristics. So it's a quite systematic to study this Mendeleev's periodic table. So that's the first importance. So just write it down. This Mendeleev periodic table, it made the study of elements quite systematic. And this also helped to the discovery of these elements at a later stage. Like after this, at that time, the discovery of noble gases हो चुका था, noble gas की discovery हो चुकी थी, and 63 elements were known at that time. Okay, Mendeleev's के time 63 elements were known. Okay. So this helped to a great extent in the discovery of these elements at a later stage. Okay, so later stage में भी जो भी discovery हुई elements के, so due to this Mendeleev's periodic table, scientists को काफी help मिला, right? Scientists को काफी help मिला to discover the more elements. Okay, due to this Mendeleev's periodic table, so they just easily just study the periodic table and the physical and chemical properties of different elements, and accordingly they discover the different elements. Okay, so it become quite easy for the scientists who discover the further elements, right, to study from this Mendeleev's periodic table. You can see. Okay. So, and one more importance is there. Like Mendeleev, he corrected the atomic masses of certain elements, right? He corrected atomic masses of certain elements with the help of his prediction, right? So you can just write. Let's see what are their predictions. For example, let's first write down this. Then we will discuss. Mendeleev, he corrected the atomic masses of certain elements with the help of their expected position and properties. And okay, so उन्होंने कुछ predictions किए, and with the help of that prediction, he just uh, corrected some atomic masses of certain elements. Let's see which elements atomic mass were corrected. So, okay, so he said that,
Ma'am, can you show the last point, please?
yeah, yeah. Okay, first write down this.
Yes, ma'am.
So importance, you can also call it as a merit, right? It is also a merit of Mendeleev's periodic table. He just simplified and systemized the study of elements and the compounds, right? And he also corrected the atomic masses of certain elements with the help of their expected position and properties. Okay, so he just helped to predict the discovery of new elements, right, on the basis of the blank spaces, right? As you have seen, he just left some blank spaces, right, in his periodic table. So it helped the scientists to predict the discovery of new elements on the basis of the blank spaces, right, in the periodic table. So let's discuss just a second. I'm drawing a table over here. Okay, now see. So Mendeleev, he just talked about he just predicted some properties, right? He just predicted or expected some positions and properties, and he gave the term eka aluminium, eka silicon, right? Eka aluminium and eka silicon were the names which was given for gallium and germanium. Us time gallium and germanium was not discovered, right? At the time of Mendeleev, the gallium and germanium were not discovered, right? So he just gave eka aluminium and eka silicon, right? उस टाइम ये अननोन एलिमेंट्स गैलियम एंड जर्मेनियम उस टाइम नहीं पता था, इनका उसकी डिस्कवरी नहीं हुई थी. बट मेंडलीव जहाँ पे स्पेसेस था, ब्लैंक स्पेसेस था, he just he just predict according to the properties, right? Various properties, he just gave the name eka aluminium, right? He just think that this eka aluminium has some properties, some similar properties just like aluminium. And similar case, just for eka silicon, he thinks that he predicts that its properties will be just similar to the silicon. Okay, so accordingly, eka aluminium and eka silicon were the gallium and germanium, right? Which was not discovered at the time of Mendeleev's. But later on, it was found that the properties which was predicted by Mendeleev for eka aluminium and eka silicon, right? These elements, they were experimentally were almost similar, right? And you can see first property उन्होंने क्या बताया, Mendeleev, he just predicted atomic mass of eka aluminium as 68. he just वो उनकी predictions थी, right? Another properties like उन्होंने density भी बताई थी, like density in gram per centimeter cube. He just predicted for eka aluminium as 5.9 gram per centimeter cube. Melting point in Kelvin, right? Formula, and I will just write formula of aluminium, eka aluminium oxide and eka silicon oxide here. Formula. First try to understand. Then if it is not clear, just ask your doubt. Okay. So he, according to certain properties, he just predicted for eka aluminium and eka silicon, right? So atomic mass, he just predicted for aluminium, eka aluminium was 68. For eka silicon, he just predicted the atomic mass as 72. The density for eka silicon was 5.5. It was not actual, right? It was just predicted by Mendeleev. उन्होंने बस prediction की थी, right? कोई proof नहीं था अभी तक. Now he predicted the melting point of Eka aluminium as it was not exact melting point. He just said that it has a low melting point. Okay. For Eka silicon, he said that it has very high melting point. Okay. And the formula of oxide, the general formula of oxide is E2O3. Right? अगर ये Eka aluminium when it forms oxide, right? Oxygen के साथ अगर मिलके ये oxide बनाएगा तो it will have a general formula E2O3. He just predicted that. For Eka silicon, he just predicted the general formula of oxide as EO2. EO2. Okay. Now for the formula of general formula for chloride, he just predict as ECl3. Right? Just like a AlCl3. Okay. So that's why he just named it as a Eka aluminium because he just have a similar properties like aluminium. Okay, aluminium agar chloride formula for aluminium chloride will be AlCl3, right? So it's just like a aluminium chloride, for Eka aluminium chloride, the general formula is ECl3. Okay, because he just predicted the aluminium, it will show similar properties as aluminium. That's why he just gave the name as Eka aluminium. Okay, for this. Now, for Eka silicon, the formula of chloride he just predicted as ECl. Okay, but in actual, but further when the gallium discovered, right, further जब इस पे experiment हुए different scientists ने इस पे work किया तो it seems like the actual atomic mass of this Eka aluminium was 70, right? Actual क्या था इसका atomic mass? It was 70, and that element was named as gallium, not Eka aluminium, because it doesn't show the properties, similar properties like aluminium. So further name क्या दिया गया? It was the gallium, okay, which was discovered later. It was the gallium, and the gallium has atomic mass 70. Okay, density was 5.94, right? And melting point is 302.93, right? Which is quite high, not low. Now, formula of oxide is oxide aims to be Ga2O3, right? Ga2, it was correct, right? ये जो गैलियम का जो ऑक्साइड का फॉर्मूला it was correct because he just predicted E2O3, and when the gallium it was discovered, so it came Ga2O3, right? The general formula was same as he predicted. Now the formula for chloride, again it was GaCl3. It was also correct. Okay, gallium Cl3. Similarly, when the germanium was discovered, right, it was found to be the atomic mass of germanium is 72.6. Okay, 72.6. But he just said this element is Eka silicon because it shows the similar properties as silicon, and the atomic mass he just predicted as atomic 72. But the actual atomic mass it comes to be 72.6 for the germanium. Okay, density was 5.36, and your melting point is 1231. Okay, and the formula is GeO2 and GCl. Okay, so that was the predicted Eka aluminium. He just Mendeleev predicted Eka aluminium and Eka silicon, but further in the gallium and germanium, it was discovered. Then the actual atomic mass and different properties are these. Okay, so clear. This table is clear, or is there any doubt, any question? So you can ask. Yes, Anidhi and Aisha, is it clear?
Yeah, ma'am, it's
Yeah,
clear.
ma'am.
Okay, so just please write it down. Just draw the table first. And yeah, it was the Mendeleev who first published his periodic table. उससे पहले कुछ publish नहीं हुआ था, right? कुछ भी written information नहीं थी, right? So Mendeleev just Dobereiner, he just initiated the study of periodic relationship, right? But the Mendeleev was the first one who is responsible for publishing the periodic law, right? For the first time. Remember that. Yeah, you can see in the table the prediction made by Mendeleev and the data which is found later by experimentally, they were found very similar. They were almost similar, you can see, right? Density को आप देख लो, आप atomic mass को देख लो, तो they were very much similar, almost similar, right? Write it and please update me. Done?
Yes, ma'am.
Okay. Okay, now let's see what are the demerits in Mendeleev's periodic table. What are the defects? Okay, so you can see, let's see the periodic table. Okay, so Mendeleev, he just placed the hydrogen atom in group 1, right? Group 1 with alkali metals. These are the alkali metals. Okay, but the hydrogen also resembles halogen, right? It also have some similar properties, just like a halogens. Right? Halogens are what? This is seventh group elements: chlorine, chlorine, bromine, iodine, and so on. These are the halogens. Okay, so hydrogen has been placed in group 1, but it also resembles like a halogen atoms in many properties, right? So that's a controversial in the position of hydrogen atom, right? So its hydrogen atom position in the Mendeleev's periodic table is controversial. That's the demerit. Okay, ये था demerit Mendeleev's periodic table because position hydrogen की that was uncertain, right? The position of hydrogen atom in the Mendeleev's periodic table is uncertain. Why? Because he just placed the hydrogen atom in first group, right? But hydrogen has uh, similar properties, like it resembles like a hydrogen in many properties, which is group 7 major elements, and these elements halogen elements. So it resembles just like that, okay, in many properties. So why it has not placed in group 7 instead of group 1, right? So this is a controversial. So the position of hydrogen is in Mendeleev's periodic table is very much controversial. That's why it has a demerit, right? So demerit of Mendeleev's periodic table, just write it down. The position of hydrogen is uncertain. It is not fixed. Uncertain. Just, yeah. Position of hydrogen is uncertain. And if someone asks you why it is uncertain, so you are now able to give the reason, right? Because hydrogen has been placed in a group first by Mendeleev, right? Because it's a alkali metal group. But hydrogen also resembles with halogen atoms, which is a group 7 elements. Okay, in many properties. That's why Mendeleev could place the hydrogen atom in group 7 also. But उन्होंने first making क्यों डाला? That's a controversial in between the group, right? Hydrogen को उन्होंने group 7 में क्यों नहीं डाला? Why he just put it in the group first? Okay, so that's the position of hydrogen is uncertain in the Mendeleev's periodic table. That's the demerit. Okay, second demerit was that there is no separate positions were given to isotopes. Okay, in the Mendeleev's periodic table, no separate positions were given to isotopes. And you know very well what is isotopes. What is isotopes, Aisha? Yes, Aisha, what is isotopes? I taught you in first unit.
Ma'am, I'm not sure, but like the atomic number is same and mass number is different.
Yes, right. So isotopes are, they have different atomic mass, but the atomic number is same. Okay, so they don't have a separate position for the isotopes in his periodic table. Okay, so because we know that the isotopes of an element have different atomic mass, but they have same atomic number, right? So this periodic table has been framed on the basis of increasing atomic mass, right, of the elements, but the different positions must have been allotted to all the isotopes, right? But he didn't give the different position or separate position for the isotopes. That's a major demerit of Mendeleev's periodic table. Okay. Third is, yeah, just a second. Yeah, lanthanoids, lanthanoids, right? Lanthanoids and actinoids are inner transition metals, like F block elements. Okay, उन्हें हम lanthanoids and actinoids बोलते हैं. ये भी transition elements होते हैं, inner transition elements. Okay, so lanthanoids and actinoids were placed in two separate rows, right? They are placed in two separate rows at the bottom of the periodic table. At the bottom of periodic table, right? Without assigning a proper reason. He doesn't tell why he just put the actinoids and lanthanoids in the two separate rows and at the bottom of the periodic table. He doesn't give the specific reason for that. Okay, so that's a limitation. That's a demerit in Mendeleev's periodic table. Right? Periodic table without assigning a proper reason. Okay, so that's the major demerits in Mendeleev's periodic. Okay, so is it clear? Everything is clear till here? Shaneri and Aisha?
Yeah, ma'am.
Yes, ma'am.
Okay, so that's all for today. I think I have another class too. So in the next class, we will discuss the modern periodic table, and which is very, very important. Okay, जो आज हम periodic table देखते हैं everywhere, so that's a modern periodic table. Okay, so we will see in details. And yeah, please just remember the atomic. I just told you in the first class, beginning class. Just remember till 30 elements. Atomic number, its atomic mass, valency, each and everything. Okay. Okay, so that's all for today. So see you in the next class. So have you guys written?
Thank you,